which coordinates are the vertices of triangle congruent to triangle ABC? So let me draw the first triangle. We have coordinates 2, 1, 2, 1. Next we have 3, 1. And we have 3, 5. 1, 2, 3, 4, 5 approximately will be here. So we can connect these points. Let's put that this is our P, R, S. First, let's find the side PR. PR, by counting, we have that PR has distance 1. So we can write that this is 1, and we see by the counting that BA has also side 1. What else? Next we have RS. We can count 1, 2, 3, 4. And we see that our triangle ABC has 1, 2, 3. So side RS is different than side BC. And what else we see here? Because the segment BC is parallel to x-axis, because the second coordinate is -1, and segment BA is parallel to y-axis because the first coordinate is the same. So we have here right angle. And we see that our triangle PRS has right triangle here too, because RS is parallel to Y and PR is parallel to X. So here we have right angle. And we see that side RS is different than BC. Only side PR is the same like BA. So it means that our triangle PRS is not congruent to triangle ABC, because the second leg is different than the second leg in our triangle ABC. So it doesn't matter what will be for hypotenuse. We don't have to calculate this hypotenuse because RS is longer than BC. So this triangle is not congruent to triangle ABC. So we can write here not. Next we have coordinates -1, 1, -3, -1, and -1, -3. 1, 2, 3. So we can connect these points. And from this graph we see that this triangle is different than this. And like before, because this first coordinates are the same, so this line is parallel to y-axis and this side is parallel to x-axis. So here we have right triangle. It's enough if we check these two legs. This has 2 units and this has 2 units too. and our triangle ABC has legs 1 and 3. So this triangle is different than our triangle ABC. So this is not congruent triangle to our triangle ABC. And now the last example. We have coordinates negative 1 and 1, negative 2, 1, and negative 1, 4. 1, 2, 3, 4. So now we have to connect these 3 points, and we have triangle. Let's see. We've got another right triangle because this side of our triangle is parallel to y-axis and that is parallel to x-axis. So here we have right angles, so we have right triangle. Let's count the legs of our triangle. This side has 1. Let's put that this is our x, y, z triangle, and we see that side x, y has 1, y, z has 1, 2, 3. So we see that our triangle XYZ has the same legs like BAC. We can write that AB is congruent to XY and YZ is congruent to BC. So we have BC is congruent to YZ. What else? We have a right angle, so for sure the hypotenuse ZX will be equal to AC or CA, it doesn't matter. So let's check the distance between points X and Z. You can write ZX, it doesn't matter, is equal square root of, and first we have to subtract X coordinates, so we have negative 2 minus negative 1 to second power plus, and now we have to subtract the second coordinates. We have x is last, so we have to keep the order 1 minus 4 to second power, so this is equal. Negative and negative give me positive. Negative 2 plus 1, so it's negative 1 to second power is 1, and we have plus negative 3 to second power is 9, so this is equal square root of 10, so this is approximately 3.2. And now we have to find the distance between point C and A. So this is equal square root of, and again first coordinates we have to first subtract, so 2 minus 5 to second power, and we have plus difference of second coordinates, so we have negative 2 minus negative 1 to second power, so this is equal square root of 2 minus 5 is 3 to second power is 9, plus negative and negative give me positive. Negative 2 plus 1 is negative 1 to second power is 1. So this is equal square root of 10, so this is approximately 3.2. So we see that sides, we can write ZX is congruent to CA. Because all three sides are congruent, it means that by the side congruence postulate, our triangles are congruent. We can write that triangle A, B, C is congruent to triangle X, Y, Z. This is my solution.